Hello and welcome back to Algebra 1 with Miss Betsy. Today we're going to be continuing our discussion of order of operations when we work with real numbers by bringing into the discussion grouping symbols, which are brackets, braces, and parentheses. If you're using the same text that I am using, we're going to be beginning on page 66, which is section 2.5, entitled Symbols for Grouping. The text I'm using looks like this. It is the second edition of Algebra 1 for Christian Schools, published by Bob Jones University Press. The third edition is not directly compatible. You'll have to flip back and forth and find what section I'm actually in. But in truth, it doesn't matter. You do not need to have necessarily a text in front of you. You can learn a whole lot just by watching this video. So let's go ahead and pray, and then we'll get started for today. Father, I thank you for another day of life that you have given to us, and I thank you for finally a hint of coolness in the air as I step outside this morning. Father, I thank you that you are creator of this wonderful world, this universe that we live in, and I thank you that you are bigger than anything we face today. Father, I ask that you would help us to be diligent to attend to our studies and to the work that you place before us today. And I pray in the name of Jesus, amen. All right, it is Monday morning. It is fairly early for me. I've had a long weekend. Much of it was fun. Some of it was just a long weekend. So this has probably got to be one of the lamest jokes that I've ever seen. Wonder if you can tell me what goes up white and comes down yellow. That, my friends, would be a raw egg. So, if you go ahead and see what I have on the board behind me, this is the last screenshot that we had in the last video. Over here on the right-hand side was an abbreviation of the order of operations that we've been working on. It said the very first thing that you do when you are evaluating either a numerical or an algebraic expression is first you look and you see if there are any exponents or powers. And you're going to deal with those exponents first in order from left to right. That's the very highest priority that you have as you deal with exponents. You also deal with radicals, which we haven't come across yet. Second order of priority, after you have evaluated exponentials, is to move in order from left to right with multiplication or division. And you see we had 5 times 4 is 20. You see we had 9 divided by 3 is 3. And when there are no longer any operations involving multiplication or division, then you move to the third level of priority, which says do addition or subtraction in order from left to right. And right here you saw that even though it was subtraction, it's in order from left to right, and addition and subtraction are the same level of importance. So we subtracted 8 minus 1 to get 7, copied the rest of the problem. 7 plus 20 is 27. 27 minus 9 is 18, to finally end up at our solution to this problem of 21. And guys, this is really what you need to be doing. I don't need you to look here and say, okay, that's 8 minus 1 is 7, plus 20, 27, minus 9 is 18, plus 3 is 21. See, you gain enough skill and you have enough understanding of the order of operations, and you can go in your head from here to here. But I want you to make sure that you're following through every step, because it's very, very important that you learn to be methodical, step by step through problems. It's not so much that you have to take 92 bazillion steps to do this, but you're learning a pattern of approaching problems that will serve you well when you get to higher levels of math, and also when you take the time to show your steps. You're less apt to make mistakes, and when you do make a mistake, you're much more likely to catch that mistake. Didn't get my markers. I guess I have 2 up here, but I wanted to have a black one also. Section 2.5 is grouping symbols. And I honestly cannot believe that I just erased that problem. But if we had wanted to change the order in which we did some of those operations so that we weren't exactly following a regular order of operation here, exponents, multiplication, division, addition, and subtraction, we could add in grouping symbols. And they are the same level of priority here as exponents. So we have grouping symbols, and we're going to see that those have the very same priority level as exponents. So let me go ahead and put on the board right here. This is a problem that I know that we worked in our teaching for section 2.4. But we're going to have 3 plus 2 times 4, 2 times 4 minus 6 divided by 3. Now, following our order of operations, first we would do multiplication, then we would do division, correct? So we have an 8 there, minus 3. 3 plus, minus 2, rather. However, we don't want, in our illustration case here, we don't want to follow what they have exactly written. Let's say that first we wanted to add 3 and 2 together, and we wanted to subtract 6 from 4. So we would have to add in some parentheses. And remember that when you have parentheses that bump right up against one another, that means multiplication, because we had that dot in between. We had 2 times 4, but we don't want to do that multiplication first. We want to override what we've learned up at this point that says first you do multiplication and division before you do addition and subtraction, and we can do that with parentheses. Parentheses are what they call grouping symbols, and there are actually 3 levels of grouping symbols. You have parentheses, you have brackets, and you have braces. And if you haven't seen already on my board work or in class on Fridays, you know I can't draw braces, so get some sort of a squiggle and let me, if you can't draw them either, it doesn't matter. You can clearly see the difference between parentheses, brackets, and braces. And what these grouping symbols do, when we use them, they override multiplication, division, addition, subtraction, exponents. They have the highest level of priority. So you listen to the grouping symbol before you do multiplication and division, or before you do addition and subtraction. And it's very much like the idea of when you're traveling and you come to a traffic light that is not functioning properly, or just an intersection that has a traffic light where there's a police officer in the middle of that intersection. And if that light says green, you would normally go. But if there's a police officer there telling you stop or turn right or turn left, that police officer overrides what that stoplight says to do, and you follow the police officer. If it's a green light and he tells you to stop, you stop. If it's a green light and you want to turn left and he tells you to turn right, you turn right. That's what these grouping symbols do. You obey them first. So here, if we solve this, 3 plus 2 is 5, times 4 minus 6 is a negative 2, divided by 3. I only have the parentheses in there to illustrate that we're doing the multiplication. I would probably myself show 5 times a negative 2 this way. Doesn't matter, whichever you're most comfortable with. Now we have 5 times a negative 2 is a negative 10, divided by 3, which is a negative 10 thirds. And that's a very different answer that we arrived at because we had these parentheses inserted. Let me go ahead and take just a second to show you the steps for this original problem without parentheses. 3 plus 2 times 4 minus 6 divided by 3. no parentheses here, we're going to do the multiplication and division first. We have 3 plus 8 minus 6 divided by 3 is 2. 11 minus 2, 9. And we used this example at the beginning of our first lecture. I said, well, if we have this given to us, what's going to be the right answer? And I stepped through several different scenarios and then said, okay, we have to be able to always come up with the same answer, so we have these rules in place that allow everybody to always come up with the same answer. And one of the problems, one of the possible answers we had that was wrong without grouping symbols was a negative 10/3. But this negative 10/3 that we have right here is correct because we have added in grouping symbols that say, do me first. And that's really all grouping symbols mean. They say, do me first. Do me first. Or perform these operations first. This pen is very squeaky today. I don't know if you can hear it as loudly as I can, but I apologize. Now, back to page 66. What if we were going to group these numbers yet another way? Let's see what we can do. See if I can selectively erase. And we're going to have the quantity 3 plus 2 times 4. The quantity 3 plus 2 times 4. Before we do our division here, what are we going to do with multiple grouping symbols? Parentheses, brackets, and braces. We work from the inside out. Usually when you're working with something, you peel an onion, you do something, you work from the outside to the innermost part. But when you're determining what order you're going to solve a problem, you begin inside out. So you work within those parentheses first. Now I have 5 times 4 minus 6 divided by 3. I have these brackets, but even here the brackets are not necessary anymore because we just have multiplication and division. But this just serves here at this point to make sure that we kept all of our operations together here. So we have 20 minus 2, which gives us a final result of 18. Different from the 9, different from the negative 10/3 that we had, but correct for this problem because this problem is different from our original example here. The grouping symbols override the traditional order of operations. Just like in the prior example where our solution was negative 10/3, the symbols occurred in different places and they overrode multiplication, division, addition, and subtraction. So, what do we do when we want to evaluate a numerical expression or an algebraic expression? Well, what's the difference first, review between a numerical expression and an algebraic expression? Numerical expressions contain no variables. There are no letters in them. Algebraic expressions always contain variables, and they usually contain numbers as well. What do? When you have a string of operations to perform on an expression, very first thing that you do is look for grouping symbols and exponents. First you're going to look for the grouping symbols, work inside there, then you're going to do exponents. Going to do multiplication and division in order from left to right, addition and subtraction in order from left to right, and it always is going to work that way. Let's look at example 1 on your text, which is on page 67. 2 plus 3 times the quantity 5 plus 7 divided by 2. We've used a grouping symbol here, the parentheses, and what that's doing is saying, okay, this is overriding my order of operations. Even though addition is typically bottom priority, it's done first because the grouping symbols say perform this operation before you do anything else. 2 plus 3 times 12 divided by 2. Okay? Two plus 36 divided by 2. One step at a time. You see that I'm working from left to right. I'm not bouncing all over the place writing numbers. Begin at the left, move to the right. Let me make sure, yeah. Division comes before addition. 2 plus 18. The final value of this expression is 20. And it's correct for this because we followed our order of operations where we have parentheses overriding the traditional rules. Let's look at example number 2 now. This is a longer problem. We have 9 minus 3 times the quantity in brackets, 2 plus 7 times 8 times the quantity, 3 plus 5, close quantity, close bracket, minus 4. Guys, when you're doing problems like this, make sure you take the time to go back and verify that you have absolutely copied the problem correctly. 9 minus 3, parentheses, 2 plus 7 times 8 times 3 plus 5 minus 4. Have two sets of grouping symbols, no exponents. We're going to work with the innermost grouping symbol first, which is the 3 plus 5. And you're going to rewrite this whole problem, and yes, you must do it. 2 plus 7 times 8 times 8 minus 4. Now, what are we going to do? We're going to work with inside the brackets. We have addition, we have multiplication. 9 minus 3 times 2 plus 56 times 8 minus 4. We're just taking this one step at a time. Now we still have multiplication within our parentheses. What is 56 times 8? If you don't want to do that in your head, 6 8s are 48. You have 448. Show your work out to the side. This, do I care if you show your work there? No. If you can do it in your head and you're confident, go ahead and do that. But don't use your calculator. 9 minus 3 times 2 plus 448, whoops, minus 4. Your brackets, parentheses, and braces, they always occur in pairs. You saw that I had to erase the parentheses. It's because it's supposed to be a bracket. 9 minus 3 times 450 minus 4. Multiplication again. 9 minus 3 times 500 is 1500 minus 150 is 1350 is how my mental math goes, but you can just do 450 times 3 over to your right, and that's just fine. 9 minus 1350 minus 4. Okay. Following the order of operations here, 9 minus 1350, we're going to subtract 9 from 1,350, and we're going to have a negative 1,341 because our negative sign is here. So we have a negative 1341 minus 4 for a final answer of negative 1,345. Now if you're wanting, for those of you who play around with mental math, easy verification here is you have negative 1350, you have 9 minus 4 is 5, so negative 1350 plus 5 gives you that negative 1345. Lengthy process, maybe a bit tedious, very straightforward though. This is one if you follow the rules, follow the order of operations, you will arrive at the correct solution every single time, and you won't be confused. You can also take, if you have a string of numbers or algebraic expressions that you want to perform multiplication, addition, division, subtraction on, you can insert parentheses, brackets, braces that will force the given solution. For example, if we have 24 divided by 4 plus 8 times 3 minus 10, and they want the solution to be negative 150. Make the answer a negative 50. You're going to have a problem like this. It says, here's this expression, insert parentheses, brackets, braces, so that we arrive at the correct solution. Is there any one tried and true method to get this? No, you're going to do some trial and error here. Let's say we'll just follow no parentheses. And we already know that's not going to work because we suspect it's not going to work because they ask us to use parentheses and braces. But we're going to try it without it. 24 divided by 4 is 6, plus 24 minus 10. You can look at that and know that it's not going to be negative 50. So that's not the way. What else could you do? 24 divided by 4 plus 8 times 3 minus 10. What if you said, put those parentheses in there. Let's group those together. 24 divided by 12 times 3 minus 10. 2 times 3 minus 10, well, that's not going to work either, is it? 6 minus 10, we want it to be a negative 50. What else could we do? Well, how about if we try 24 divided by 4 plus 8 times 3 minus 10. 6 plus 8 times a negative 7. 3 minus 10 is 10 minus 3 is 7. You use the negative in front of the 7. 6 plus a negative 56. This right here is the solution that they're asking you for right here, because they said insert grouping symbols so that you end up with a result of negative 50. Now, it took me 3 steps here, 3 tries to get it. It might take you 5 or 6, but they're wanting you to really practice working with grouping symbols to help you find, they're having you do this exercise just to give you some additional practice working with parentheses, brackets, and braces. I'm going to do one more example, and this will be from your homework. And I'm going to go ahead and pick number 10, on page 68 to use as our final illustration. Page 68, number 10. 10 plus 3 minus quantity 4 times 8 minus the quantity 7 minus 8 times 6, close bracket. Am I skipped? Remember I said make sure that you go back and verify. I think I'm skipping between two problems here. I am. 10 plus 3 minus 4 times 8 minus 7, quantity 7 minus 8 times 6, okay, times 9. I was combining 10 and 11. Now I'm going to even look one more time. 10 plus 3 minus 4 times 8 minus 7 minus 8 times 6 times 9. Okay, you're thinking, oh goodness, there's a bunch of junk going on. There is here. It just means that it's going to take up some paper. Okay, paper's cheap. If paper's a problem for you and you're in my class, let me know and I'll buy you some paper. Seriously, because I want you to be taken step by step by step. Look at the innermost grouping symbol. We have 7 minus 8. 10 plus 3 minus the quantity, 4 times 8, minus negative 1 times 6. All of that times 9. And let me see what the answer is here. It's going to be a negative 329. We have within the parentheses multiplication and multiplication. We have parentheses here. I said within the parentheses, it's within brackets. But we have this multiplication and we have this multiplication. It can be done at the same time. 10 plus 3 minus the quantity, 4 times 8 is 32, minus a negative 6, times 9. When we subtract a negative number, same as adding the opposite. So this is going to be 32 plus 6. 10 plus 3 minus 32, not 32. 32 plus 6 is 38, times 9. What do we have now? Addition, subtraction, multiplication. We go ahead and do 38 times 9. Off to the left, 8 9s are 72, 7 27, 7 34. Hopefully 342. 10 plus 3 minus 342. 10 plus 3 is 13 minus 342. How do we add, subtract oppositely signed numbers? Subtraction, same as adding the opposite. When you have opposite signs, keep the sign of the larger after you have subtracted. Negative 342 and 13, you subtract those numbers, you get 329, and it's a negative. And this is what your answer is. I probably, possibly would have benefited by saying, okay, maybe up here, 4 times 8 was, if I had inserted the wrong answer here, we would have tracked through this. I would have checked my answer and seen, oh, I did something wrong. And then I would have gone back through the problem and said, okay, here's where I made my mistake. That's what I want you guys to be doing. That's why I give you access to the answers and I tell you to check your own homework before you come in, because I don't care that you have just run through the homework to spit out nonsense on a piece of paper. It does you no good if you miss half of your homework. When it's a value is when you can say, okay, it's supposed to be negative 329. I got a negative 329, or let's say that you did this subtraction wrong here, and instead of subtracting, you added, and you get 355, but it's a negative 3, and you put that here. Check it and say, okay, I've made a problem. made a mistake. See if I can catch this. This step looks right. This is right. Oh, I'm supposed to subtract. And I added. Let me go back and correct this. 329. Now I have a negative 329. Let me check that answer again. Okay, now I'm right. I can go ahead on to the next problem. And that's all I have to show you on this. Have a good time working with these, as much of a fun time as you can with math. If you get stuck, send me a text. I'll see you on Friday.